Good day, viewers. You are welcome back to my channel. As you already know, my name is Israel. Today, we are going to have a look at three simple practicals. The first one is identification of different solutions by using litmus paper test. Second one is identification of solute, filtrate, and residue using a mixture of starch and water. While the last one is a test for carbon dioxide. As I would like to inform you, most of these tests, they are what you need to know. They are what you need to have as your first-hand knowledge before you go into real salt analysis. For example, the test for carbon dioxide is expected that you must have had the previous knowledge of it during the classwork experiment, because when you are writing your external exams, maybe WAEC, JAM, NECO, nobody is going to allow you to carry out this test in the lab. It is believed that when you see vigorous effervescence, you should know that carbon dioxide is liberated, and you have to write for them the results you are going to get today. That is why I deem it fit that most of these tests we need to carry it out before I go into salt analysis, because subsequent classes we are going to face salt analysis proper. So let's get started. Like you can see, these are three solutions, colorless. If you smell it, they are odorless, but don't taste it. Odorless. So that you don't know which one is which one is water, which one is acidic, which one is basic. When we say basic, we're also talking about alkaline. But the only way we can easily know is by using litmus paper test. You can see this is a pack of litmus paper. We just take some from it. This is blue litmus paper. We also need the red litmus paper. You can see this is the red litmus paper. You can use it for this. You need to touch the water. The water will always be neutral because it has a pH of 7. You see, it produces no color change. No color change too. So it's just moist or wet. It means this one is neutral solution. Neutral solution, pH of 7. Then we go to this. If it is alkaline, it will not affect the blue litmus paper. It will only have effect on the red. Let's see it. You dip it into it. You see there is no color change. Then when we dip this into it, let's see what will happen. It is produce blue color. Change the color of litmus paper to blue, meaning that it is alkaline. Then if you go to the acidic one, if it is acidic, it will definitely not have any effect on red litmus paper. Let's use this little one remaining. You dip it into it, you have no effect. Then when we add this one to it, you see it has changed the color of blue litmus paper to red. With that, we are able to identify that this one is acidic, this one is alkaline, and this one is just neutral solution. So that is the first experiment we have just done. Then let's go to the second experiment. The second experiment is simply identification of solute, filtrate, and residue using the mixture of starch and water. This is water. We have already prepared the solution, but I can still increase the quantity. You see it. This is starch solid. As you can see it, solid added to solution that contains added to water. You see it. Let me increase the quantity so that we can be able to filter it properly. This is spatula, what you use to carry the sample into this boiling tube. You can see the difference. This is a boiling tube, this is a test tube. Boiling tube usually bigger. You see it. This one is now a mixture of water and starch. It cannot mix together. Therefore, we have to filter it. Remember, this salt we are adding is known as the solute. A solute is a substance which is able to dissolve in a solvent to form a solution. While the water we added is known as a solvent. A solvent is a medium which is capable of dissolving a solute to form a solution. So we now add, we are going to filter. Before we filter, we use a filter. This is a filter paper. There are many types. Some are smaller, but this is one of the big size, although there are also others that are larger than this, depending on what you want to filter. So you fold it. This is how you fold the filter paper, turn into a cone. One, fold it again. Two, it's now become the shape of a cone. You open one part of it where something is not able to pour out. Then this is a funnel. Place inside the funnel, ensure that the hole is not there. You can see it. Then what you are going to filter, stir it very well. You can use a glass stirrer, but you can also swirl it like this. You just turn it into it. You just wait a little. You can see it's gradually dropping. You can see it dropping. That which is passing through, which is able to pass through, is not the solid starch. It is the filtrate. The filtrate is what is passing through. Then what will remain on top is called the residue, which is not able to pass. Before we end this topic, I will show you the residue. So the residue, it continue to go through, the filtrate continue to go. The one that is passing through the pulse of the filter paper is known as the filtrate. But the one that will remain at the end of the day on top of the filter paper is known as the residue. Before the complete filtration process completes, let us go to the last part of the practical, which is known as test for carbon 4 oxide. To carry out test for carbon 4 oxide, there are simple materials you can use. You can use any material that contains a triisocarbonate 4. For example, calcium triisocarbonate 4, which is commonly and is readily available. That one is known as limestone. You can easily get it. But what we are going to use today is zinc triisocarbonate 4. That is what is in this container as a solid. So how are we going to do it? We are going to use zinc triisocarbonate 4. So let's rinse this. Just rinse it with water. This one is called a delivery tube. This you are seeing, this colorless solution you are seeing is known as lime water. We are going to add it to this. There is nothing here. It's just an empty test tube. So we just add the lime water into it. You can see the lime water, the quantity. Let's reduce it a little. So that's the lime water. Then this one we have already removed the liquid that is in it. We can add let's add the triisocarbonate 4, the zinc triisocarbonate 4. So you can see we have added zinc triisocarbonate 4. So we are going to try and be a bit fast. By the time we add the acid into it, we quickly insert the delivery tube. Just watch it. We cover the mouth with it so that the only outlet is this, and we insert it into this gas. You see vigorous effervescence we are talking about. You can see the effervescence, you can see the water, you can see the bubbles, and the color is gradually changing to cloud. It's changing cloudy. You can see it like cloud. That is lime water turning milky. You see it as we shake it. Carbon 4, you see the color have changed. It gradually become thicker as more carbon 4 oxide is being released into it. You can see it gradually become thicker and the bubbles continues. You see the color is gradually changing. Nobody will allow you to do this in your WAEC examination hall. It's believed that you have passed through this stage and you have known it. You can see it becoming thicker and thicker. So this is the simple test for carbon 4 oxide. Lime water turns milky. You can compare it with the solution from which it was taken. You see the difference. This is the milkiness we are talking about. So when you pass carbon 4 oxide into lime water, when it's released from the triisocarbonate 4, you see that it reacts with the calcium hydroxide. This calcium hydroxide is also known as lime water, and it forms a solid, which is the white precipitate we are seeing here. That is the solid. Now let's go back to our second experiment and see if our residue is there. You see it has stopped, the filtration process has stopped. You can see the solution under the filtrate is colorless. Then let's see the residue. You can see on top. You can see what is on top. Thick. That is what is called the residue. You can see it. Thick. This is called residue. It's the one that couldn't pass through the pulse of the filter paper. So, friends, that's how you identify different solutions using the litmus paper, and that's how you carry out test for carbon 4 oxide. You can see it turns milky. Then that's how you also identify the filtrate, which is able to pass through the pores of the filter paper, the residue, which is unable to pass. Thank you very much, and God continue to bless you richly.